All right, math people, here is a lesson recap for Chapter 1, Lesson 4. What happened in Chapter 1, Lesson 4, you say? GCF happened. What is GCF? What do those three letters stand for? Hopefully you remember. Greatest common factor. So when we're talking about the GCF, we're talking about the biggest number that is a factor of a set of numbers. Remember, factors are, for example, if you had the number 16, some of the factors for 16 would be 1 and 16, 2 and 8, 4 times 4 is 16. You get the point. The factors are the numbers that multiply to get a number. Now, I gave you some strategies for finding the greatest common factor. The first one was you could make a list of the factors of a set of numbers and then compare that list. So for example, let's say you had the numbers 24 and 40. The factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Then I've got to list all the factors for 40. 1 and 40, 2 and 20, 4 and 10, and then 5 and 8. Now that I have all the factors listed out, I'm looking for the greatest common factor. So which number is the biggest that's in both of these lists? Well, if I go through, I can clearly see that the greatest factor that's common between these two is 8. So the GCF of 24 and 40 is 8. That's the largest factor that they share in common with one another. Now, if you don't like the list method, or if you encounter a problem where it's like, whoa, this number is big, it has a lot of factors, how can I possibly list them all without making a mistake or missing one? We talked about another strategy for finding the greatest common factor, and that was using upside down division. That's at least what I'm calling it, and let's take a look at how this method works. Find the greatest common factor of the two numbers 12 and 56. So to do this, using upside down division, we had said first start by writing the two numbers, 12 and 56, and then we set up what kind of looks like a division that's flipped upside down. And you ask yourself a simple question. Is there a number that can go into both 12 and 56? Any number will work as long as it can go into both of them. I'll start small and say these are both even numbers, so 2 is something that can go into both of them. Now, how many times can 2 go into 12? 6 times. How many times can 2 go into 56? 28 times. And I'm going to repeat that line of questioning. Is there a number that can go into both 6 and 28? Again, 2 can go into both of those. They're even numbers. So 6 divided by 2 is 3. And 28 divided by 2 is 14. Is there anything that can go into both 3 and 14? The answer to that question is no. So at this point we can stop, and you can get your greatest common factor, your GCF, by doing this. Look at the numbers, the factors that went into both of those numbers. We had a 2 and another 2. If you find the product of those two numbers, or in other words, if you multiply those two numbers together, that will tell you what the greatest common factor that they share is, and that is 4. So upside down division is a cool method. It doesn't matter if you take multiple steps to do this or if you do it in one step. So for example, if I had 12 and 56 again, and someone said, oh, I know 12 and 56, 4 can go into both of those. 12 divided by 4 is 3. 56 divided by 4 is 14. So you'll notice that I still got to the same ending two numbers, 3 and 14, 3 and 14. And I still got the same GCF. The greatest common factor, the number I pulled out of here, is a 4. So it's a cool strategy. It's a shortcut as opposed to using the list method. Let's look at another example. and we'll do 32 and 90. So I'm going to start by asking myself, is there anything that can go into both 32 and 90? And I know that since these are both even numbers, I could divide them both by 2. 32 divided by 2 is 16, and 90 divided by 2 is 45. All right, we're at a point. Can anything go into 16 and 45? I say no. Neither of those numbers share a common factor. So we're actually at a stopping point after just one step, and that tells me that the greatest common factor of 32 and 90 is 2. The biggest number that they share as a factor is 2. If you made a list of all the factors, that would be the number that they have in common, the biggest one, 2. We'll do one more example, and let's do one with 3 numbers. So find the greatest common factor, 45, 75, and 120. Doing this works the same way. Is there a number that can go into 45, 75, and 120? I notice that 5 can go into all of those, so 45 divided by 5 leaves me with 9. 75 divided by 5 leaves me with 15, and 120 divided by 5 leaves me with 24. All right, is there something that can go into all 3 of these numbers? The answer is yes. All of those are divisible by 3, so they share a factor of 3. 9 divided by 3 is 3, 15 divided by 3 is 5, 24 divided by 3 is 8, and now I'm at a point where there's nothing that can go into 3, 5, and 8, so I need to stop. I'm going to look at the numbers that I used as factors. Common factors were 5 and 3. If I multiply those two together, 15. That's the greatest factor that's shared between 45, 75, and 120. If you made a list of all their factors, that's the biggest one that they'd all have in common. All right, that is the end of this quick video recap lesson on greatest common factor. Hopefully it's helpful. As always, if you have any questions, feel free to reach out to me. Otherwise, happy mathing!